Hi, hello. My name is Kiran Kumar. I am your physics lecturer. Today topic is plane mirror. Welcome to my channel, Nature of Physics and Art. What is plane mirror? Plane mirror is a piece of flat glass with one side is coated and a remaining side is a reflected surface. And here on the plane mirror, the angle of incident must be equal to the angle of reflect. So the condition is angle I is equal to angle R. On a plane mirror, this is the incident ray and this is the reflected ray. And a reflected ray always only in one particular direction. Okay, so next we are considering characteristics of image formed by the plane mirrors. So take an object O and light releases from the object. So somewhere other there is a source, light releasing from the source and incident on the object. From the object light get reflect and also on the plane mirror it again reflected. Okay, so two rays we are considering, that is here converging rays or diverging rays. These are the diverging rays. Okay, see here these two incident on the plane mirror, after reflection this is also taken as a diverging reflected rays and this give the image of the object O. So how image form here? With the help of extending the reflecting rays. See, a reflecting ray extended and here also reflecting ray is extended. This give the image of the object. So I is the image. Okay, so next one here, the object distance is must be equal to the image distance. See, the object distance is taken as here x and image distance also must be equal to the x only. So this is the x distance. So that is the distance between the mirror to the object, which is equal to the distance between the mirror to the image. Try to understand. So this is the x taken here, the distance from the mirror to the object and also is equal to the from the mirror to the image. Okay, so then next one is the image is upright image is formed. Okay, and third point is here the image is formed by the plane mirror is laterally inverted. What is that? Laterally inverted. For that here left side is appear like a right side and the right side is appear as a left side. Okay, so right left reversed image will be formed with the help of plane mirror. Okay, for example, this is taken as a plane mirror, here taking A, B, C letters. Okay, so the image formed by the plane mirror is C, B and A. So the distance between the object and the distance between the image from the plane mirror is equal. And here this image is what type of image formed here? This is a laterally inverted image. C is reverse here. B also reverse. And A as it easily will come because of symmetrically that is same only. Okay, for example you taken here L letter. Here you will get L is like this. Fourth point here, the image size must be equal to the object. Always the image size must be equal to the object. And last point, fifth point, the nature of the image always opposite to that object. Considering a point object O here, light releases from the point object and light gets reflected from the plane mirror. Okay, see here light get reflect and extending the reflected rays and that will coincide at one point, that is taken as image. So here we are considering this is real object and the image is taken as virtual image. Okay, so always object distance must be equal to the image distance here also. Okay, then continuation here the object is at long distance, some other place, and light releases from the object, that is taken as here converging rays, which is incident on the plane mirror that reflect and give the real image, and extend the incident rays that will give the virtual object. Okay, so from both diagram we can understand one thing here, that is due to the reflected rays the image is taken as the virtual image, due to the extending the incident rays that give the virtual object. Try to understand and please copy this. Now continuation, field view of image in a plane mirror. Try to understand step by step. Considering a plane mirror AB, O is the object, light releasing from the object, three rays are considering these are diverging rays which are get reflect from the plane mirror, also taken as three diverging rays, and these three rays are extended which is coincide at one point that give the image. According to the properties, the object distance is equal to the image distance, the distance from the mirror to the object which is equal to the distance from the mirror to the image. Here x is equal to x is taken. How we can identify the field view of the image? The reason is here we will get the field view of image in the direction of the reflected rays only from the object. Other than remaining other places we won't get the image of the object with the help of field view of image in a plane mirror. Try to understand. Here we can observe this area of the image of the object only. Other than from this area we can't see the image of the object. We can see the object directly but we can't see the image. Okay, try to understand. In the field view direction, due to the reflected rays only we will get the image of the object. Now second example, here also we are considering plane mirror. Here AB is the plane mirror, but in the case of first one, that is vertical direction plane mirror, here we are considering horizontal direction plane mirror. Here object is y distance from the plane mirror and object releases the three rays, that is diverging rays which is incident on the plane mirror which get reflect, and this is reflected rays and extend the reflected rays which is coincide at one point, that is taken as the image. Image distance must be equal to the object distance. Okay, so when we will get the field view of image with the help of reflecting rays from the plane mirror, see, other than this direction we can't see the image. Here we can see the object directly but we can't see the image of the object without in the direction of field view of the reflected rays. Okay, so for example, observer here observing the image, we can't see the image. For example, observer here, okay, observing the image, we can't see the image because of in the direction of reflected rays only we will get the image of the object in the plane mirrors. Field view of image of a plane mirror with two examples just now completed. Now here one important point, every plane mirror irrespective of its size that give the image of the complete object. Whenever the size of the mirror is increases, the field view of the image formed by the plane mirror also increases. Whenever size of the mirror is increases, then what happens there? Field view also increases. That's why here every small mirror also that give the complete image of the object. Okay, please copy this. Now field view of an observer. Think practically. I am an observer. Okay, so there is a plane mirror on the wall. I am observing, okay, the images of the object in a room. That's why here I can see only few images. Okay, now if you change the position of observer, like move right side or left side. Just again observe the mirror. You can identify the images, but not initial images. Reason is the position change of the observer, the images also you can see with respect to field view of an observer only. Try to understand. See here, we are considering observer. He is looking into a plane mirror that is taken as a B, which is fixed to a vertical wall. So the observer observing the plane mirror. So this is the direction of field view of observer. So here he can only see the few objects. See, considering here 4 objects, O1, O2, O3 and O4, that will give the images I1, I2, I3 and I4. Try to understand here. O1, O2 give the images and I1, I2 corresponding distance x1 and x2 respectively. We know the object distance is equal to image distance. See here, 2 images only the observer observe from this position. Because of here 2 objects only give the images in the field view of an observer. Whereas in O3 and O4 objects, these 2 also give the images, but these 2 images does not in the field view of an observer. These 2 images I3 and I4 other than the field view of an observer he can't see. If he change the position, then he can see or can't see the images of the I3 and O3 of corresponding objects O3 and O4. Try to understand the field view of an observer in a plane mirror. Now, the minimum size of the mirror required to see our self-image. So considering a plane mirror AB which is fixed to a wall, and taken an observer. He is the observer. He is observing his self-image in the plane mirror AB. So the object distance must be equal to the image distance, that is x equal to x here. And observer observing his self-image. So the self-image nothing but he have to see the full image of the observer. So here he is observing the full image, head and also legs clearly. So now we have to consider here right angle triangle is there. For example, if we consider this is the theta, so we can take here tan theta which is equal to the first value is AB divided by CA, and next also we can consider tan theta which is equal to opposite is DE divided by adjacent side is CD. Now both values are equal. Tan theta is equal to tan theta. From this equation we can write here clearly, that is AB divided by CA which is equal to DE divided by CD. Now H is taken as height of the object, nothing but image also. So here we can consider H is the height of the object, or we can take image. Because of in a plane mirror the size of the image which is equal to size of the object. See now here the values here AB which is equal to CA into DE divided by CD. Try to understand. The values considering here CA is taken as X, so AB which is equal to X, and DE value is taken as H divided by, okay, CD value is X plus X is 2X here. X and X get cancelled, so we will get here, okay, AB which is equal to H divided by 2. AB is equal to how much? H divided by 2. Okay, how much size of the mirror required to see the self image? Okay, the half of the height of the person. Okay, we need the plane mirror. The minimum length of the mirror required to see the self image is half of the height of the observer. Okay, so here AB is the, okay, plane mirror, that is AB. So size of the mirror which is equal to half of the, okay, size of the observer. Okay, so for example here observer height is 6 feet, then how much size of the mirror required? The length of the mirror must be required 3 feet. Okay, the person height is 4 feet, then how much size of the mirror is required here? 2 feet size of the mirror is required to see the self image of the person in a plane mirror. Thank you.